Okay, so let's start our lesson. So on the first lecture on the discipline technology of construction production, I want to speak with you about concrete constructions. Generally about some problems there are was or can be or would be really big problems in the concrete construction when during the installation of main constructions in concrete buildings was some failures, some mistakes, some constructional errors which lead to the big problems. And actually not only that mistakes, but in combination with the other weather and climate problems, with climate impact. So in combination they create together some problems for several buildings. And I want to start from this slide to show you the building which was collapsed in the Africa continent in the Kenya. So this picture and the information was took from the size nighttimes.com. So here you can find some information about this building. So when the concrete building was collapsed due to climate, actually first aim was the climate actions. So there was the heavy rains. So in the actually you can read some information about it. So it was in the last year in December 6th, 2019. The six-story residential building collapsed in the Kenya in Friday after weeks of heavy rains. So directly heavy rains cannot be reason when the buildings, any type of the buildings can be collapsed, actually. So if there wasn't any problems in the building. But in the combination with the problems, with the failures of the building, of course, it can lead to really not optimistic problems which took the people lives. And here you see that 4 people were dead and 29 in jury after the building was collapsed. What is the most interesting for us? Of course, it is to try and understand what happened and what was the main causes and the main problems why the building was collapsed, and how to prevent in the future the same problems for building where you will be a part of designers, if maybe you will took participation in the construction, on the construction site, and so on. So you need to actually know about all reasons which can lead to main problems with concrete buildings. Actually, concrete buildings nowadays, you know it, that it is one of the popular buildings in the construction field, and through the years it is only grow up and became more popular due to there are many really interesting, popular, and very helpful investigations which increase the quality of the concrete constructions, which decrease the time of construction, so decrease the total budget for construction, and so on. But in the same time, of course, should be solved the problems which lead to the failures of the buildings, and we need to know it. So for that, actually, especially for that buildings, there can be found five main mistakes, which was found during the investigation. So there are some problems with the internet. I'm sorry. So let's continue.
Вас очень тихо слышно.
There was a little problem with the internet connection, so we will continue. So during the investigation of collapsing that building, there was determined main five reasons why the building was collapsed. And let's talk about each of that problems. Foundations are too weak. So a weak foundation is the biggest problem for any type of construction, because not adequate bearing capacity of the foundation, you know, that can lead to the collapse at the beginning, at the finishing of the construction, and so during the operational time. So in any time can become a problem, because weak foundation is not strong enough, not that foundation which will be live with the building during the operational time. That's very important. Why can be found the weak foundation? First of all, the foundation, good foundation, can be costly, so the cost can be higher. We know that the cost for underground part of the building, in general, it is about 1/3 of all costs, of all budget cost on the construction. So it's approximately 30% of all budget cost. It's a higher, really a higher price for the substructure of the building. But there are many reasons why it should be really strong, because it can be failure. And so foundations should be protected well. It should be protected by the special organizations who know how to design the foundations, who can apply right foundation. And also there are main and maybe most important thing, it is to make on the construction site, before the design works will be start, you need to make the investigation and to make some reports about the earth, about the ground soil conditions, and so on. So you need to take some tests of the ground soils. So during that laboratory testings, you will find all layers under the future building, so all type of characteristics of them, and so on. And because designers who take part in the accepting type of foundation, size, make the calculation of foundation, first of all take into account the information about soil conditions. If there are no investigations about soils, so it will be better not to take that project and begin to design that project, because it will be big mistake not to take into account the ground soil conditions. Generally for these buildings, developers save money and should spend on foundations when building on the city's swampy ground, and many buildings have collapsed. Swampy ground, it is a really hot conditions for the construction. Approximately the same conditions we have in our regions, especially in our capital. So near to our capital, there are swampy ground soil conditions. That's why it is sometimes can doubly increased building cost, for example, for skyscrapers, because to assure the stability, bearing capacity of the such buildings, we need to apply the really difficult to design and construction types of foundation, like spiral foundation, and also they will be very deep to transmit all load not on the swampy ground soils but to the hard soils. Even on a solid ground, foundations need to be strong enough for the load. And of course, not only not only ground conditions play the main role, but also this foundation itself. So what type of concrete was applied, what type of reinforcement was applied, and so on. So many questions are solved during design the foundations. And so if the foundation designed not right, if the basement and the foundation also was mistaken, we have really many examples in our city. So the micro district Al-Ghabas, you know that there are many buildings with the same problem. There was settlements and the differential settlements under the many story buildings for not one building. So a few buildings was near to the collapse, but in the time there was repaired by the organization Kaznisa, and there are again some buildings have the same problem, and nowadays the work how to help them again be stronger enough to live in them. This problem are solved now in the Kaznisa. Next, building materials are not strong enough. So I became talking about that concrete and reinforcement should be also strong enough. And when we are make the design of a project, of course, we try to apply the concrete which durability will be sufficiently enough according to the calculation. And then when we accept the fresh concrete, you know it, I told about that fact, we need to check it every time when the mixer with the fresh concrete came to the construction site, and you are just putting the fresh concrete into the ready forms of constructions. So you need to take some examples, take some from new concrete and create some cubes, and after a few days, like 7 days, 14 days, 21 and 28 days, when these cubes of concrete will lay in the high humidity box, will be it water or sawdust with water. After then, you need to check it in the laboratory on the compressive forces. And so if the results of testing will be enough and they will be equal to the calculation properties of the concrete. Only in that case you can be guaranteed that your concrete is sufficiently enough to carry out all weights from the construction, so like exposed actions and so the internal forces. That's very important. And not only concrete should be tested, but also steel should be tested. So steel, I mean the reinforcement should be tested. You need to cut off the welded reinforcement from the main constructions, like columns, for example. So there are several rebars, steel rebars, which are connected to each other. And so that connection, a welded connection, should be cutted off. And then this cutted element, so welded connection, should be tested on the special laboratories, and again the results should be the same like calculated results. There are market for counterfeit materials, going as far to say that some metal is used instead of steel. So counterfeit materials can be found not only in that regions, but also in our region. We know it that it's not new information for us that sometimes the materials from, for example, China. So I can't say that all materials from China, it's not high quality materials. Some materials actually is really high quality and they're very good and strong. But sometimes there can be found the more cheaper materials from the China, which builders in our country too. It's not not new information for us that most really often used in the construction site. That is a big problem. Workers make mistakes. Workers' mistakes, it's a responsibility for engineers. So if you are responsible for the construction site, you are the foreman on the construction site, you took engineering education, you are specialist in the construction area, so you are responsible for all mistakes happen on the construction site. So be accurate. Your workers make mistakes, so it means you make mistakes. That's why it can lead and kill not only workers on the construction site, but also people who will live on that construction site. So the load is heavier than expected. We know that during making the calculation, we add on the main constructions the most important and main loads on the construction. Yes, so they are live loads, permanent loads, storm shot loads, and other like seismic loads, wind loads, snow loads, and other blow loads, for example, some other variants of the loads. But sometimes there wasn't calculated correctly. Not all loads was taken into the account during calculation. And if there are some facts of not taken into account all loads and they became heavier than expected, of course, it is additional problem for main constructions. It is negligible deformations. It is um, cracks, micro cracks for main construction, and in total, in future, it is increasing size of cracks, and of course, it is failures, deflections, displacements, and so on. And in the end, it can be collapse. And the strength isn't tested. All points of construction, the strength should be tested. So as I told you, during construction, after construction, all main bearing elements should be tested on the verticality, on the horizontality, on the durability by using non-destructive method of testing that nowadays it's very popular and more easier than destructive method. Non-destructive method just need to take from you some time and knowledge how to use new equipment which help you to check the quality of the concrete, the quality of the steel, and so on. So let's talk about some problems which can be found on the in the monolithic construction. So violations when the pouring concrete structures. During installation, areas void, missing below blending, filling with polyethylene inside. So we know that we need to protect our foundations from the corrosion, from the heat losses, and so on. So it should be installed well without any crashes, without any mistakes. Again, here we see improper filling that all connections between the main plates should have the tape. So it is special tape lines which avoid the growth losses in the construction between the main panels. So during construction, engineers should be very accurate and put it into the construction because the main recommendations is to tell that there should be located the taping in the joints. You need to clean all construction before you will apply the fresh concrete. So cleaning before, during, after rebar formwork installation, it is important part of monolithic works. Because if you will apply the fresh concrete, it will be not connected with steel with the lowest ready construction and will show the not so good results like it would be if there will be cleaned surfaces and the ready surfaces of below located constructions. Also corrosion, if there are someone should be cleaned. So in general, there are no permission to apply the fresh concrete if there are corrosion on steel. So corrosion firstly should be killed by the special cleaning liquid materials. There should be a void of broken rebars. So all rebars should be inclined and stiffened, which is other but not broken. A concrete cover. So protecting concrete layer should be actually like it was recommended according to the special documents, but not less than it's recommended. So every time you need to look at the thicknesses of cover to protect future reinforcement from the corrosion. For each construction, the thickness of the protecting concrete cover is not same, and it's special for each of construction. Also, it depends on the thickness of the rebar, steel rebar. Using plywood as supplement for concrete cover blocks. You see that the plywood is the most often useful type for formwork, and it also can be used to create the thickness of the concrete layer, like you see on the picture. So concrete protective layer can be made by using the plywood. Verticality and horizontality should be again done properly, and you see that it is again made by the plywood, but what is not right actually, because it should not be in the construction during it will be monolithic. So when pieces of wood is used, so like you see here, so stick by nails before concrete casting, not during the concrete activities. So all works should be finished before the concreting activities was started. Storage of rebars. So all rebars should be stored in the closed space, not on the open air, because the raw will be found very quickly. So if there will be absence of the water, but there will be found the corrosion. So preservation, proper handling, and rust.